I have the pleasure to give you an introduction to voice assistants. I looked over the website of VNRJS and I was like, why has never anyone done about that topic? It's really cool, it's really fun, and it's really easy to do. And I'm not seeing a lot of projects out there. So I thought maybe a little motivation goes a long way, right? Who of you has a voice assistant at home, like an Alexa or Google Home? Right, okay. How you like it? Yeah, good, there's a good, yeah, good. Rock on, it's always good, yeah, nice. I thought, hey, why not do both? Because don't want to be biased. So whenever you have this icon on the slide, that's very specific to Alexa. And if you have this icon on your slide, that's very specific to Google, right, to Google Home. I tried to keep it as consistent for both of them, but sometimes obviously they diverge. Cool. Who the fuck am I? Oh, am I allowed to say? Okay. So my name is Jacob. I'm one of the founding partners at the Venturi. I work there as the chief lead for backend and data engineering. So I care about the backend, I care about data, I care about stuff moving. And I'm also an evangelist for chat and voice bots there. So I love stuff that talks. I'm also an I'm an ESO committee member on the Joint Technical Committee on Artificial Intelligence, which is cool because lots of stuff happening in that field, and we're trying to standardize it on the international level. Cool. That's my company. Whatever, do cool. We do cool stuff. We invest in startups. We work with big corporates. So it's super fun. You see a lot of different tech. So diving a little bit into Alexa, right? So not a lot of people know that there's about 100 million Alexas being sold and in households out there. And the prediction for 2022 is there's actually 200 million Alexas out there. So you have a really massive amount of devices that is sold in households, ready to be used. And then you look in the Alexa skill store and it's basically empty, right? So you have this device, people are using it, but no one is there, right? And all the marketers in my company always tell me if you have something like this, go onto it because you get all the attention if you're the first one in that market. So what's very specific about Alexa is they used to be voice only. They tried to really go for voice commands and voice assistants. But they're now starting to open up with screens and buttons and stuff like this, mostly through the pressure of Google, I think. But that's impressive. But now wait for Google. So the Google Assistant is now on 500 million dedicated Google Assistant devices, right? And then over 1 billion Google Assistants, that obviously also includes the one on the smartphone, right? Because Google, right? But nevertheless, the 500 million dedicated devices with Google Assistant is really impressive, I think. And what I think is really interesting with Google, it really bridges the whole band. It's voice, it's text, it's touch, right? The Google Assistant is very broad in its term of going into different modes that you can communicate with. So it's quite challenging to also program a good experience on it, but it's fun. So how does it work? Try to keep it super high level on the architecture. You speak to the device, and the device speaks to you, and you listen, right? This is kind of this loop here, right? And the way you plug into the platform is that you have kind of a switch. I'll get to that later. And then you have your action or your skill that runs on the platform. Right? It's kind of your app or your attention span taking over the communication with the user. And then it's super primitive. You have a webhook that goes to your preferred Node.js server, obviously, and then you send a response, right? What's sometimes really interesting is that communication here happens synchronous. So that might sound like something fun because I get a request and then I just output the return JSON and that's it, the communication. But it's sometimes really a problem because Amazon or Google, they don't want to wait. So they give you 10 seconds to answer with the response, right? So the timeout is actually pretty tough. And 10 seconds may not sound that long if you have a small app. But if you, example, integrate into like an insurance company and you go way deep into their core system, you're starting to like pile up on response times. And suddenly you're like at 10 seconds response time because you're dealing with a system from wherever, right? And then you're starting to like come close to that response time, which is sometimes a problem. So fast is really cool here. But yeah, the basic is that with the webhook, you kind of get all the information you need to process your request, essentially. And then in the response, you give basically the answer that is then funneled through the system to the user and you hear it, right? And what's really interesting with those kind of systems is you have no visual output, right? You don't have anything, no buttons, no select boxes, nor check boxes, nothing. So hearing and the art of hearing really becomes important, which is fun, because suddenly your voice becomes your brand. When we think of like making websites, everything what our brand represents is visual, right? It's colors, it's styles, it's formation of the platform. But none of that happens, or none of that exists normally in a voice-only communication. So the way you speak, the words you use, the tempo, right, the acoustics, stuff like this becomes your brand. The way you speak, right? There's a really good explanation, like if you call an airline company and the person on the other phone says like, howdy, where do you want to go today, right? That's a very different brand than, hello, how may I help you, right? You have an immediate different person in your head, and that's the brand, right? That is on a voice-only communication, your brand. So it's very interesting to also think about what kind of character do you have? Because we always have a character, right? When humans communicate, even with something like Alexa or Google Home, we tend to imagine a character in our head. So we have to consciously design that, which is fun because it very much reminds a lot of people on the beginning of the web. We say like, oh wait, maybe we have to like put forms into a consistent way, and like maybe we should think about the flow of the application. So we're in that very early stage now with the voice communication. But anyway, super fun to think about it. So how do we get to this branching thing, like between you and the other one? So this is called an invocation word. So you give it an invocation word, and with Google, that is globally unique, and with Alexa, that is device-specific unique. So for example, here, you can say, hey Google, ask Meetup about the next VNRJS meetup, right? And here you have an explicit mention of ask Meetup, so this would be your invocation name. But you can also have on Google the implicit, which is really nice, because you can say, hey Google, when is the next VNRJS meetup? So you're not dedicatedly mention the invocation word, but Google kind of gets from the context and the VNRJS that you want to reach the meetup skill, right? And then tries to redirect you to your own skill, which is nice because a lot of people tried this without the dedicated, and then they like find you. There's an implicit way of being found on those platforms. Alexa has this currently in beta, so it will also roll out in the near future. So a little bit of words, because obviously in the visual one, we always know what words means, but for the voice one, it's maybe interesting to also get the words that we use there. So when we call it what we call an utterance, which is basically what someone says, right? It's the input that you get. For example, the user says, when is the next VNRJS meetup in March? That's an utterance in the sense that it's an input that you get. What you can classify out of it in the first step is an intent. What is the intent behind that utterance that the user says, right? The intent behind this is he wants to have the meetup time, right? This is kind of like the broken down business case or the broken down case that your application needs to process later on, right? And then obviously you can get a lot out of this utterance, right? You know, for example, that it's looking for the VNRJS meetup. That's not just any word in the sentence, but to you that word has a very specific meaning. It means the specific event that they want to hear. Maybe they're looking next time for the Vienna PHP meetup, right? Or the Vienna gardening meetup, right? So this word has a very specific meaning for you, and we call this an entity or a part of speech. And then there's a second very interesting part of speech in there, which is in March, right? You probably don't see it, but in March, which is the month that we actually get. Because it makes a difference if we're looking for the VNRJS meetup in January or the one in March, right? So this is like an entity that we have to detect. So how are we going to do this? Yeah, so obviously this goes into the training, and we need to tell the platform that those are words that we kind of care of because they make a difference for the sentence. So how does the training work? I hope everyone can see. So this is the interface you get from Amazon Alexa. And what you have here is you enter in sample utterances. So you train the system by entering what a user might say, right? And you give him like 10, 20, 100, 1,000 different samples for that single intent. So you're always training on an intent basis. So the intent here is meetup time, and I gave him a couple of trainings, say like, what time is beep in beep? So month, meetup and month. What's happening in beep month? Yeah. So you tell him where you have your entities in there, and it kind of learns how the structure of the sentence works by merely entering those. So it would detect that what's happening in January, what's happening in March, what's happening with April, then automatically comes because it knows that the structure of the sentence should be that. And you can even train it without an entity. When is the next meetup? Right. You don't have all the information, so you might prompt the user afterwards, like, hey, which meetup you're looking for, which month you're looking for. You have to then later guide him through a step of the dialogue. But ideally, the user provides everything, for example, in this sentence. So that's how you train an intent. You give him sample utterances, and it kind of learns from those sample utterances. And that's also the learning later in the system, is that you carefully log if there's an utterance you didn't know and you can't classify, and you put it back into the training. It's like, hey, this you did wrong, this is that intense, and vice versa. This is how it looks in Google. They're using a platform called Dialogflow, which was a startup they acquired a couple of years back. And you also see it here. This is like the utterances here, and here you have the entities already marked. When is Vienna.js in March, right? They actually, like, you can actually write it down, write it out, and you see that. What you also see here is that is from the entity meetup, and that's a date period. So it automatically detects date periods, which is super nice, because then all the date periods work, right? It's kind of like, comes out of the box with Google, which is really nice. So, why Node.js in the backend? I think for everyone in the room that's quite obvious, because Node.js is cool, and it's very easy with 4 lines of code to like write a simple server that allows you to take that webhook and immediately then responds with the JSON you would need, right? So we found that Node.js is actually pretty awesome in that regard, because it's fast, it's very lightweight, and you can generate those request response pattern quite easily and quite stable. And also like lots of serverless, because speed is of the essence. If you talk to Alexa, if you talk to Google Home, you don't want to wait a couple of seconds until you get the response. You want to have a more fluent conversation. So speed is really important here. So start thinking about serverless if you don't have a cold start. So how does it look with Alexa, right? So you get like a massive JSON out of it, right? I tried to reduce it so it fits on one slide and it only holds the information that are necessary, but that's a huge JSON. You get stuff about the session that's currently going on, about the context that the conversation is, what user, where's the user's location, what's the device ID, stuff like this. And then you get that request with an intent request. This is when you get an intent that was invoked in the platform. You get the local, so you know like, oh, this is from an English speaker. And then you see here, you get the meetup time, the intent that you classified. And then you get like the slots, which is the entities as Alexa calls them. And then you have like meetup, and here you have the Vienna.js meetup, and here you have the March. And that's what you then basically run against your database, right? You do some formatting, you do some corrections, you look how it works, and then you Google, hey, meetup API, give me for Vienna.js everything you have in March. You filter that back and put it back into into Amazon Alexa here, right? How does it work? The response, you give it a version, super easy, session attributes you can forget, and then you have a response, output speech, type plain text, right? And then you have the actual text that Alexa should say through its text-to-speech mechanism. Super easy, and you'll mostly get good results. There is a second type which is really interesting. It's SSML, speech synthesis markup language. In there, it's basically text with markup language where you can actually like control the pronunciation exactly. So if you have, for example, a horrible word which is the venturi, which is really hard to pronounce even for a human rather than a text-to-speech synthesis mechanism, you can give it the exact sounding words and the sounding louds, and then it would make its best to actually make it that sound, which is really nice, especially if you're dealing with brands or very specific words that don't come out good through the normal text-to-speech synthesis. With Google, it's also very easy. You get this query request. Again, here it's really nice. You get the plain utterance that the user says, which is super nice, because if you don't trust Google to do a good job, which sometimes you should, then you can run it on through your own natural language processing or your own natural language understanding, or even through your own TensorFlow, and like see if Google did a good job. And then you get the parameters, and then you basically, as you can see here, you get your entities here. Same thing with Amazon Alexa. And you basically also get the core intent here, as you see, meetup time. And then here you even get an intent detection confidence. So it's very nice from Google to tell you like how confident the machine is that they have made the right choice for you. So for example, you can say, oh, I only trust 80%, and if I get something that is less than 80%, like I'll cut it and like go through a fallback procedure or any other dealing mechanism, right? Again, this is the essential fields. This is a very long JSON with a lot of data that you normally get, but that's the core fields. So, and then you respond. The response is very sleek. You give it a fulfillment text, which is basically, again, the text that you want to speak. And then you give it a source, so it can attribute it to your server, and then some context and flow output that I don't want to go into because it's a little complicated. And that was easy, right? That's all there is, right? You get an intent, you take it, you classify it, you do your inner workings with it, and you respond to it. And basically the rest is the magic that happens in the box, right? It's the rest that the Amazon Alexa or the Google Home cares about. So basically you're writing the pure backend and let the front end and everything handle a lot with Alexa and Google Home. So that's easy, especially if you're doing like a small application that, for example, you automate something in your home, or you write a notification service. You can ask like Google, hey, are there any new notifications and stuff like this? But I want to give you a little bit of sneak peek, because that's obviously not the way we do it in the company. And I thought it would be nice to see how a system like looks in production if you roll it out to a multinational corporation, how a system on a bigger scale looks like, because I think then you're starting to see a pattern. So we have something that we'd like to call the bot base, because it's a nice name and it kind of like shows how it works. And what we built is, we built not just Alexa and Google Home, but we built like a lot of channels, and we put them through a harmonization layer in saying like, we don't want to care too much about the specifics of the platform, but we want to have something abstract to work with, that a developer who's not familiar with each individual platform can still work with the platform on an abstract level, right? So taking the specifics out of the interface. And then after the harmonization layer, we run it through the actual custom business logic that we have, right? This might be like handing in an insurance claim, or it might be like triggering something, or putting a sales offer, or even an FAQ, or something very simple. We run it through it. And sometimes we use one of the platforms above. Sometimes we use our own methods. It's actually super flexible. Sometimes our work was already done. For example, in the Amazon or Google Home, they already come with the intent. We don't have to run through the intent detection again. And then we Google on the end some enterprise data or some databases where we have some knowledge about the user, right? So actually you want to dive not too much into the specifics, but you want to abstract it very quickly so a lot of developers can get onto the source code and don't have to read through a lot of materials of documentation. So yeah, that was all. I hope it was a short introduction, and happy to get the questions.